dividing, all that kind of junk. Basically, this works out to be a lot of factoring and simplifying. It is very, very simple.
Wait, multiplying, dividing what?
That's all. Multiply, divide, rationals. For example, if I wanted to simplify this, this basically says polynomial divided by polynomial. As I go to do these problems, I'm not going to write down the problem as I see it. I'm going to factor it as I go. It's just going to save me a step. Okay? There's really no reason that you have to write down the whole problem. So what I'm going to do is what times what's negative 12, and you add together to get negative 4.
6 and 2.
Negative 6 and 2.
Negative 6.
So I get terms of x minus 6, x minus 2, divided by x minus 2, x plus 2. It is. And that allows me to have, I want you to notice that everything now is written as terms. Everything's being multiplied together, which means I can simplify out pairs of 1. What simplifies? The plus 2's. So you get x minus 6 over x minus 2. Why is this answer not 3?
Why would it be? You can't cross out over.
Right? You can't simplify over addition, so you're done. You can't cross anything else out. You can't do any of that kind of junk because of the addition. You can only simplify when things are terms. Things are parentheses, multiplying straight out. When I go to multiply two things together, again, as I start it, all I'm going to do is factor everything as I'm writing it down. Because in the end, terms will simplify themselves out. So when I start the first one, excuse me, I get 4x minus 4x squared. What's the first rule of factoring? What's my GCF there? 4x. So if I factor out a 4x, I get 1 minus x. You okay with that?
Yes.
What times what's negative 3? You add together to get 2. Negative 1, 3. What times what's negative 6? You add together to get 1. Negative 2. Okay, what drops? A 4x and your x plus 3. Are we okay with that? Now, see what you're left with. 1 minus x over x minus 1. Sorry, it's in the numerator. And x minus 2. What can you tell me about 1 minus x and x minus 1? Yeah. So they're very similar. If I factored out a negative 1 out of the top, what would you get? Yeah. If I take out a negative 1, I get negative 1 plus x, which is x minus 1 over x minus 2. Sometimes they'll sneak something like that at you. Because now what drops? Yes, and you wind up with negative 1. You can. That's an okay answer. It's an okay answer. If you want to distribute out, it's a lot of times with these things, you can you would simplify out your numerators. You could leave your denominators in terms, but if it's just negative 1, you'll see as we go. A lot of times in your numerators, you can't do anything with denominators or what drops.
Is this always
Pretty much it.
It's easy. Although I can't jinx it because then the next problem.
What happens when you divide? Do you guys remember the rules for dividing? Multiply by the reciprocal. So
Simple.
yeah. So right off the bat, as I'm writing the problem down, I factor everything as I go. What's the GCF 3x minus 12? So automatically, as I go to do my division problems, I'm going to flip the second fraction and factor it as I'm writing it down. One less step to worry about. Okay. So what times what's 8? Yeah. Yeah, you're gonna get -6. And then take the GCF out again. And dun dun dun. Dun 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 dun. No. Chicky.
Why doesn't it come in negative? Like, because I just discussed the reciprocal, so positive should become negative.
You're thinking of reciprocal for when you're worrying about slopes, opposite reciprocals. We're just multiplying.
It just doesn't matter that it's a division sign in between the two, it isn't changing it.
No, you just flip the fraction. Because we're dividing by 2 is the same thing as multiplying by a half. That's all it is. We don't do any properties really with division. We just flip it and make multiplication right away. It just makes your life easier.
Then you flip the first one, and then you flip the second. And then you change the first one.
Oh no, I'm so frightened. What do I have to put over or underneath 3x minus 5? Excuse me. Can I factor anything from those first two terms?
No.
9x squared minus 25, what do you get?
3x minus 5 and 3x plus 5.
Very good. Difference of squares. Question?
And then you have your x plus 5s, and you have dangling left.
So even though you guys, Cooper's like, oh, what's going to happen? It's going to get scary. Yeah, it does a little bit. It's really nothing different. Okay? It's really nothing different. It's just a whole lot of factoring to simplify. Factoring to simplify. Okay? Questions on that? Well, let's do the fun stuff then. And that's where things are. What happens a lot here is if you go to graph some of these things, if I had you guys graphing stuff like this, these are the polynomials that when you get more in pre-calc next year, when you graph them, this is why you're going to get poles. You're not going to have asymptotes at -5 and positive 5/3. You're only going to have an asymptote at -5/3 because the other ones factor themselves out, but yet you still can't divide by that 0, so it's a pole in the curve as opposed to an asymptote. You deal with that more. Now, the second part of this then is that we use it in adding and subtracting. So when you add and subtract fractions, what do you have to add? This help.
Yeah. Other ones, why can't you take the x out of like subtract that right from that?
Because there's an addition.
But on the one above here, you did. Oh.
So, for example, what did you have to do here if you had to add a fraction? Be at the common denominator. Now, a lot of times when you guys got common denominators, the easiest thing to do is just to multiply the two numbers together. What's the common denominator between the 6, excuse me, the 2 and a 3?
6.
Thank you. 2, paying attention. So if I wanted to multiply this out, my common would be a 6. Well, what do you have to multiply the 3 by to turn it into a 6? 2. So what you did is you multiplied by a factor of 1, because 2 over 2 is, and you got 4. And here you multiplied it by 3 over 3, and you got. So your answer would have been 7/6. The trick of multiplying by a factor of 1 is something we do all the time. We did that when you first learned how to do this. What'd you multiply top and bottom by?
Root 3.
When you rationalize the denominator, you multiply by a factor of 1. When we dealt with I, we multiplied by 1 plus I, which is a factor of 1. It's all the same basic principle. This whole idea of multiplying by a factor of 1 to allow you to simplify stuff goes back way back in time. Yeah. One thing that they brought up in third hour is this problem. I had to get a common denominator. Now, there's 2 ways of going about doing this. I can multiply the 2 numbers together and get 48. You guys agree? If I do it this way, here I get 6 minus the 8, and I get negative 2 over 48, which is negative 1 over 44.
That's unnecessary.
It is unnecessary because that meant you were lazy. You didn't use the least common denominator. Do you remember how you got least common denominators via prime factors? Prime factors. How do you rewrite 8 as prime numbers? 6. So what do they have in common? 3 2s and a 3.
How do they have a 3 in common?
Sorry, let me rephrase this. Well, what do they have in common? A 2. What's left?
2 2s.
What's 2 times 2 times 2?
4.
Times 3.
20.
Which meant this side needed to be multiplied by a 3, and that side needed to be multiplied by 4. What was left? What's happening here, in order to get what's called a least common denominator, you're looking for the next number that they go into. The shortcut way was doing the factors of primes. What do they have in common? You write it down. What's left? 2 2s and a 3. So we knew that the smallest number that the 8 and the 6 would go into is a 24. Well, the 8 had 3 2s. Our common denominator has 3 2s and a 3. So what is this fraction missing? A 3. This fraction has 2 2s. Excuse me, 2 and a 3. It's missing 2 2s. Yes, sir.
Okay, so this method works with these like little numbers, but when you get into like really big fractions, it's usually faster to like do it the other way, like the top way, because like it takes so long to find the prime factors.
Right, but we're not dealing with numbers. We're rarely dealing with numbers.
Okay.
What we're dealing with more often than not are going to be terms.
Okay.
Okay.
All right.
Let me do this one first. What we're going to do is deal with terms. Okay. And it's basically the same exact process. So I have 7 over 5x plus 8 over 3x. Obviously, I can't add them together, they don't have the same denominator. So we figure out the common denominator first. What do they have in common? They have an x in common. These guys are already factored out in terms of prime, so these are in common. Cross them out, we already wrote it down. What's left? A 3 and a 5. So I have 3 times 5 times x, 15x. Okay. What is the fraction on the left missing? 3. So I have to multiply the top by 3. What's the fraction on the right missing? 5. So you wind up with 21 and 40, which is 61, or 15x.
How do you convert x minus 5 to prime?
We're going to worry about in terms of factors. We'll factor first, then we'll it's it's all the same process, just look for it. Okay. Let me go back to the one I had up here a second ago. Same idea. What I'm going to do is I'm going to factor stuff as I can. Excuse me. So I get 5 over 6x squared. What do those guys have in common as far as GCF?
4.
Take out 4x. Excuse me. I have an x minus 3. Okay. Now, do I need to go through the whole process of listing out prime factors for a 6 and a 4? What's the next number that 6 and 4 both going through? 12. You okay with that? Now take a look at your values of x. One of them has an x squared, the other one has an x. What would be the next factor they both have in common? X squared. Remember you want, because there's 2 of them on one of them, there's only 1 on the other. So you have to have an x squared. And then what's left? The x minus 3. Think of it this way again, if you want to go back to primes. 2, 3, x, x. 2, 2, x, x minus 3. What do they have in common? That's why I started with the 2x. What's left? 3x. And that's what I'm doing. I'm just saying it out loud. Okay. I'm still prime factoring, but we should be able to do a lot of that prime factoring off top of our head. Okay. Excuse me. So if I look at the fraction on the left, how do I turn a 6x squared into a 12x squared times x minus 3? In 2 of times the quantity x.
Yeah.
So I need to multiply the fraction on the left by a 2x minus 3. And then how do I turn a 4x x minus 3 into a 12x squared x minus 3? It's easy 3x. Like I said earlier, your denominators don't need to be simplified because they're already written out as terms themselves. Numerators, you want to multiply and combine like terms. Okay? You're always going to multiply your numerators together and combine like terms.
No.
So I get 10x minus 30 plus 3x squared. Yeah, I'm just going to rewrite that here in 1 second. It looks cleaner. Now, sometimes in your numerator, there might be a quick GCF you could get. They're all even, something along those lines. You might be able to catch something like that. Otherwise, the only thing you could do now is check to see if you can factor them. Or, what is the zero of the, what are the, excuse me, rephrase this. What are the zeros of the denominator? 0 and 3.
0, 3.
I have multiplicity at 0 and a 3. Are we okay with that?
Yes.
Okay. Now, obviously in the numerator, I'm not going to have a 0 of 0. You guys agree with me on that?
Correct.
But if I had a 0 of 3, that means I can do one of two things. I could synthetically divide by 3 real fast and see if I get 0. Or, use your calculator. Put 3x squared plus 10x minus 30 in your y equals. Go to your table. It's just as fast.
If you don't give us a calculator on the test.
Then you can do this. Whatever, you guys are like, what? What I'm doing here right now is checking to see if x minus 3 is a term of 3x squared plus 10x minus 30. If it was a term, I could synthetically divide by 3 and I would get a 0 at the end. Remember that? It's obviously not going to be a negative 30 when I use synthetic division here. So can I factor that and simplify it? No. No, I can't. What I'm getting at here is you always want to just quickly double check your numerator if it's a quadratic, if one of these things can factor out. It doesn't always work, but sometimes it does. This is a shortcut way of doing it by checking it with synthetic, because you're checking it from the 0. Yes, sir.
So what are we looking for when you go?
If you go in your table, that's the other way I was going to say, if you had a calculator, I put it in my calculator and I go to my second table. I'm looking at 3 if it's 0. If it's 0, woohoo. If it's not, don't worry about it.
It's
So you go to the next problem. That just means you're done. You're done with that problem. Your answer is this. Okay, that's what your answer would be. Do another one. Excuse me.
If you scroll up, how come you can't just cross out the x minus 2?
Plus sign. You can only simplify when you have multiplication. When everything's written out as terms, you want to simplify. Yes, sir.
So, are there gonna be problems where like you have to simplify several fractions, and then add them together and then simplify that?
Absolutely.
That sounds like fun.
Let's try another one. Do subtraction. Excuse me. So if I use subtraction, I'm going to do the same thing, guys. As I'm writing these problems down, I'm going to factor them right away. It's because it's easier, it's a little bit quicker. So I have it's x plus 1. What times what's 4 get together to get 4? 2. So we're going to get x plus 1, x plus 2, x plus 2, minus, what's the denominator on the other one? Common denominator. What do they have in common? They have one set of x plus 2's in common. What's left? Don't multiply out denominators. Leave them as terms. Okay? Leave them as terms. I think sometimes you might get answers in the back of the book that'll have multiplied out. Don't. It's a waste of time. You don't need to. Put your foot down, please. There you go.
Add
Excuse me. So, fraction on the left. It already had 2 of the x plus 2's. What was it missing? Here. Notice I threw parentheses up because I have subtraction. You will get that wrong, so you're gonna forget to distribute.
Wait, I'm confused.
What?
Where did that x minus 2 come from?
See how these guys already, this one already had 2 of them?
Yeah.
It was missing this, so it needed to be multiplied by. I had to multiply top and bottom on this side of the x minus 2.
Oh, okay,
I'm turning it into a common.
got it.
One on the right needs another x plus 2. Okay. Always simplify numerators. Combine like terms, all that kind of fun stuff. So we're going to get x squared minus x minus 2 minus 2x minus 4, I believe. Which gives me and you could probably tell right now what times what's negative 6 to get negative 3. Oh, not enough.
Wait, hold on. What's the first black number, or first black polynomial that you wrote?
2 times x plus 2.
No, I'm talking about that you. Alright, so it's a fraction, fraction in black.
Yeah.
The polynomial. What is that?
I FOILed out x plus 1, x minus 2. And then I'm distributing out and simplifying my numerator.
Oh.
Not to factor, they're already factored. I'm telling you, don't multiply them out. Don't FOIL them out. Yeah, don't multiply them out. No reason. There's no reason. It's already in factored form. That's a great question. You never need to worry about denominators here. And what she was asking is like, because they are your zeros, they are going to be your asymptotes. If you had to graph them, they're already done for you. You don't need to remultiply them out because the numerator is what you have to do with the addition or the subtraction. You'd be combining like terms. The numerator is what might be able to be factored. The denominator already is done for you, so you don't have to simplify it again. That's all. So don't ever worry about multiplying out. It's unneeded. Okay. Let's do some more.
Hey, don't worry about this. This is easy.
Wow. You guys complain a lot.
We can, so you,
Welcome to the Wandons.
That was
no, he
other classes probably think you once is coming.
Because you guys always complain when you see.
This is a
No.
He's obviously
So nowhere near that. You can rewrite the way that works, right?
This is called a complex fraction. This is it's fraction over a fraction. What I want you guys to think of this is as very similar to this. One half divided by 1/3. It's written vertically as opposed to horizontal right. This is the exact same thing as saying this. Which is the exact same thing as okay.
Mr. Moore,
Hey there.
why couldn't you just multiply the entire thing by 1 over x plus 2 plus 2x over 1 over x plus 2 plus 2?
It gets too messy. Because what you wind up with here, in this part here, is there anything I can do? But here, I need to add these two together, which means I have to get a common denominator. So when I start these types of problems, I normally do write them, because you're going to have to do addition and what, you have to do a lot of addition between these. What I would do is write it out vertically, but then break it into smaller problems. Excuse me. So in the denominator's denominator, what's going to be the common denominator between an x plus 2 and an x? And?
1.
No.
2.
Think of these as terms, guys. Think of those as terms. So the common denominator there would be x times x plus 2. Don't multiply it out. You don't need to. No need. It's a denominator. Don't ever worry about multiplying those out. Right. So now I'm just working on the denominator part right now. Don't care about this right now. What is this fraction missing in terms of this? An x. What's the fraction on the right missing? Which means I can simplify it. The numerator of the denominator is 3x plus 4 over. Are we okay with that? Yes, sir.
Okay, so for the numerator, it's you took the thing that was missing from the first one. Oh, it was a 1. Never mind.
Yeah, I just wrote it.
Okay.
So now I have original numerator divided by
Correct.
that's in essence what I wind up with.
Oh,
And so just immediately just flip it.
that's easy.
So all you're doing here is really 1.5 problems per. So when I flip this, and if you're comfortable enough just flipping it right away, go for it. No problem. Now you're all set up in terms. Everything here is a term. You can simplify out. And you are done. There's nothing left to take care of. Let's do another one. That's something.
Wait, just one sheet back.
Ah.
How do you get this? Oh, okay, put it over there. Thank you.
Oh my
This would seem like
Yeah, she could have made it more easy.
Remember, guys, what you're going to wind up doing here is you're doing one subtraction problem, then you're doing one addition problem, and then you're just multiplying them together, is what it works out to be.
No.
You've got to get a common denominator from the top, got to get a common denominator up there, rewrite it, get a common denominator down here, rewrite it, and then just multiply by this one's reciprocal. So, x over x minus 4 minus 4. What's going to be the common denominator of that? 4 times the x minus 4. Good. The subtraction in between. Fraction on the left needs a therefore, fraction on the right needs the x minus 4.
You're doing the top one
Wouldn't it
and
be
the bottom.
4x?
Yeah.
No. I'm up here. Oh, I'm sorry, X, thank you. I'm got a really bad head cold going. Sorry about that. I thought you were talking about the bottom there. Okay.
Can you back up a second?
I thought it was, when I quickly looked, I thought it was in 1. That was my fault.
I'm happy for you, but at the same time, I lose.
So now you have to simplify that numerator. Simplify out that numerator, you wind up with 3x plus 4. Distribute the negative. So you get 4x minus x plus 4. Now at this point, I'm leaving it alone. I don't multiply out that denominator, it's not worth it. Common denominator here is going to be a 4x times the x minus 4. This one needed to be x minus 4. This one needed the 4x. Distribute out your numerator. Now the last step is to take the numerator, x plus 4, over 4 times x minus 4, and multiply by this part's reciprocal. And what drops? X minus 4. I can't because it's terms. Each of these are being multiplied. Okay, so it does work. Which means your answer is x, 3x plus 4 over. And it just so happened that you wound up with a denominator that you had multiplied earlier. And you just think like that. Because you know how it was a numerator earlier, we had to simplify it out by multiplying it. In this case here, that denominator just winds up being written out. What is the only value, or what are the two values you could try and see if it does work synthetically? Negative 4/3 or 0. Obviously 0 is not going to work, but if I just took negative 4/3 as a fraction in my calculator, substitute in for x, can I just do that too? I don't think it works. It probably won't work because we did everything in terms of GCX and stuff like that. One of the things that does happen, if you did not use GCX, or the least common denominator, if you use the idea of just multiplying everything together all the time, the last steps you can do a lot more simplifying. By getting that least common denominator, you have less work at the end to do. Questions?
Can you multiply, like, can you bring that x over, or on the numerator?
You don't need
Is
to.
it not with it?
No. Because that's what I'm saying, is because once you get to terms like that, a lot of times you'll see things are going to drop. Because if I'm looking at it, if x was able to factor out, if I have to have 0 for the denominator. 0 won't give me 0 in the denominator, so it doesn't work. And then I would just check, I can use my calculator and do negative 4/3 to the third power times 4 plus 20 times negative 4/3. And I don't think that works either, so. We'll give you some more.
go back to the sitting. Like, I mean, she seemed kind of like stressed out, like, along with this too. And I wrote her this note, she, like, we were supposed to hang out yesterday, and, like, we were gonna go for a hike and everything, and she was, like, really stressed out.
Do those.
About, like, let her hang out for a little while, and just get her to, you know, release a little bit of stress.